Hello, and welcome to today's Agremo's crop monitoring webinar. Thank you for taking time out and being here today. I am Nevena, Marketing and Communications Manager here in Agremo, and I will be your host for today. I've spent 15 years in agriculture and marketing as well, but always with focus on new technologies and their use in real life, on real farms and with real results. And also what I want to emphasize that you will definitely leave today with very useful information, how our analysis work, some successful usage of Agremo products, as well new options from a sales perspective. We also have a surprise for you, so please stay tuned to learn more about it. Also, please feel free to drop questions or share your struggles and experiences in on the right hand side of your screen. There is a question box, and immediately after the presentation, we will have a live Q&A session. Just immediately after the let's say this official part. And please don't worry about making notes immediately, since we'll send the sessions recording your way in the following days. So with us today are my colleagues, Luca and Nemanja. Luca is he's a mechanical engineer, but he also brought an AI technology to more than 100 global companies. He still spends a lot of time explaining the technology and its benefits to the end user, but he feels progress. The time he needs to do that now is more than half, let's say, compared to 5 years ago. Also, Nemanja is a precision agriculture engineer with expertise in electromagnetic soil mapping, navigation system, GIS, and remote sensing. He worked for one global company, and he was responsible for precision farming on 55,000 acres, which is about twice the area of Manhattan. And he's most proud of the achievement, of course, with his team, because his team managed to raise the overall efficiency of agricultural machinery by an average of 86%. Our belief is that precision ag technologies will find its place in all agricultural production systems in the near future. But it is also our obligation to educate and to support our end users. So, Luca, please start. Okay, and let's start with the presentation.
Hey, thank you, Nemanja, for the introduction. Hello, everyone. Thank you for attending to our webinar. So today we are going to talk about how technologies such as drones and AI analytics software can help ag professionals to improve their field scouting and crop monitoring operations throughout the season. We will share what kind of crop performance information could be gathered with Agremo, and share some of the successful cases on how growers and agronomists use seasonal data to improve yields and optimize crop production. I will make a short introduction about the Agrimony company. It is a cloud-based software that uses AI to extract data from aerial imagery. It is a tool which is specially designed for the ag industry, and its purpose is to provide data about the crop performance in different stages. I emphasize that it is an AI-based software because the AI technology allows us much more than vegetation indexes that are currently used. So it allows us to extract data, but what is important to mention is that it allows us to detect and quantify some specific stresses. So As we all know, field crops are grown outside under the open sky. So from planting or even before the planting until the harvesting, there are many factors that might affect the yield. Egg producers who are doing such a responsible job of supplying us with the food have to make many decisions during the season in order to have high yields. But what is also important is to be profitable. This is true now more than ever due to a large price jump of ag inputs that we are all now aware. Smart decision making requires information that cannot often be acquired in a simple way. The most common information growers and agronomists have is the area before the sowing and average yield after the harvest. If we want to improve yields, we need to check our fields throughout the season and understand what can be done to improve the situation and what to expect at the end. Due to the natural aspect of agriculture, crop performance and monitoring are often limited to a labor-intensive and not very efficient activities. Most of you know how it looks like to walk all your fields on foot and scout crops. It is hard work, which can be very challenging also due to weather conditions. With Agremo and drones, seasonal monitoring should become highly effective, as mapping and analyzing a, let's say, 100-acre field takes about an hour, and I'm talking about every square foot of the field. So in a seamless way that can be easily implemented in your daily activities, you can have a better and highly accurate understanding of crop performance throughout the season. This means that you will not only know how much to sow and how much you harvested, but you will also know the yield lowering factors, their exact location, and how much has each of those factors contribute to the crop performance. You can get information such as stand counts, stress level, weed pressure, plant vigor, waterlogged areas very fast, and you will have the reliable data that you can work with. So now with this tool, we aim to empower agronomists in their day-to-day operations, help them to improve the decision-making process throughout the season. This tool will help growers, agronomists, ag professionals to be more efficient and to provide you with the precise data and point out areas in the field that require your additional attention. In the end, you are the one who is making the decision, but with this technology, you will have a colleague that is always available and ready to help you. So to talk more about the AI analytics and the ability that we can have with such technology. So, for example, we have the field that is present here, where we have two stresses on the same field all over the field. So we have the weeds and the diseases that are present. But now with the Agremo and AI, we can set the software to detect specific stress. So we can differentiate weeds and set the software to focus only on detecting and quantifying weeds. So you will have the information about the size and location of the weed zone throughout the field. So AI analysis such this will allow us to pinpoint the stress location, prepare appropriate maps for variable spraying, and understand how much each stress factors are affecting the yields. So with this seasonal crop monitoring, we will be able to understand the factors as well as potentially understand what led to further development of the stress zones. Information that we are able to provide are the stain count analysis. This is our first analysis that we developed and something that recognized us in the ag industry. We have successfully applied the stain count analysis on over 100 different plants, from field crops, industrial plants, even in the forestries. We have the weed control analysis. As I explained in the previous case, software is able to differentiate weeds from crops and focus on providing information about the size and location of those weed zones. We have the stress detection analysis, where software detects everything that is not a healthy plant. We have this plant vigor analysis. It is our new analysis, which considers 3 factors: plant population, canopy coverage, and NDVI. So the software will tell 4 zones with the different vegetation status based on those 3 factors. We have the water logging analysis, which is using the drone data and the elevation map. So we can put the focus on detecting the water loggings and the potential waterlog areas. We have the canopy coverage analysis, which is providing information about the vegetative cover versus the ground coverage. So now I would like to invite my colleague Nemanja to share some successful cases on how ag professionals are using this analysis and this information to improve their field production.
Thank you, Luca. Before we jump into the use case itself, I would like to give our listeners a bit of a backstory in how the entire project that we're going to go over came through. Early last year, Agremo was invited to join a collaboration of some of the largest regional precision ag providers in order to develop a full service solution for the growers. Full service means all field operations have precision ag involved into them, meaning from soil preparation till harvest. When talking about precision agriculture and field operations, we have a lot of data that is constantly being generated, and while we can use telematic systems to confirm that those operations we intended to execute were in fact executed as intended, we need a reliable crop monitoring solution that can confirm that those technologies are yielding positive results. That is how Agremo came into this story that we're going to go over. First, I would like to describe the project that was executed during the last production season. The field that was chosen for this project was the size of 20.7 hectares and was divided into 2 equal parts, as you can see on the image on the right side of the screen. One part was conventional practice where no additional technologies were applied, and on the other side, all operations were supported by precision ag technologies such as variable rate fertilization and variable rate sowing. And as you can see on the right, something is different with the map, and that is the map of variable rate sowing that was used for analyzing the number of plants, which we will discuss a bit later on. The crop in question was corn. Same hybrid was used on both sides of the field, so the same genetical predispositions were on both sides of the field. And pre-sowing fertilization was applied with flat rate on both sides of the field to ensure early equality for the crops. Additionally, both sides of the fields were irrigated in order to avoid any potential drought stress that could have been caused. In order to successfully set up the following project, we had to confirm the uniformity of both sides of the field. First thing that we did with one of our partners, we mapped the entire field for electrical conductivity to confirm the uniformity of mechanical composition. We have proven that both sides of the field have a small range from 62.4 to 78.8 microsiemens, proving that the highest content in both sides of the soil was clay, and therefore proving the mechanical uniformity of the soil. We have run arable area analysis, which has confirmed that there are no gaps in the surface area where production can suffer losses, and also elevation points analysis was run in order to confirm the elevation uniformity of both sides of the field. Additionally, now we will speak more about the analysis that have been done in depth, but first analysis that was run throughout the season was checking for weed pressure, but the presence of weed was negligible during the entire season, so we won't be discussing any further data about that. First, the most important data that was done was the stand count analysis. As I mentioned, on the precision ag side of the field, the sowing was done using variable rates application, and therefore had a better distribution, more appropriate to the conditions on the field. We can see in the chart on the left side that we have had a higher application of seed in the conventional agriculture, where the entire field had the same amount of seed per hectare applied, but our total emergence rate was 26% lower compared to the sowing rate. While on the precision ag side, we have lowered the total used seed about approximately 50,000 units, and we had a germination rate that is only 11% lower from intended, or in other words, we had a 15% better showcase on the precision agriculture side. Without Agremo, we would have to go on the field by foot and have to select our random spots to check the number of plants, which are subject to unfortunate mistakes in results based on the person who is doing the selection. This way, we had insight into the entire field at once, and we could objectively compare data and quantify it easily. The next important analysis that we ran was plant stress, which was ran throughout the entire season, and some averages of those results, where we can see that with flat rate application of fertilizer and flat rate application of seed, the areas located on the conventional agriculture side of the field had 11% higher plant stress compared to the precision agriculture side, where we can see the uniformity on the field. And what is interesting in this case, that we can see that on both sides of the field, on the left side we have a red stress line, which was expected because the field is located near a channel which is open to a lot of stresses. But on the conventional side, in the middle of the field, we can see direct impacts of flat rate applications and treatment without any additional technologies or improved decision making. As I said, so we used variable rate fertilization. The rates for fertilization application were decided based on soil sampling that was done prior, and the fertilizer in question was urea. On the left side, where this plant vigor analysis was done after the application in order to monitor the absorption success rate of the crops. And on the conventional side, we can see that the absorption rate was not as successful as on the precision agriculture side, and that is quantified through the plant vigor's excellent vegetation status. Luca has explained in detail how plant vigor analysis works. So here we can only track that only 2% of the field had an excellent vegetation status on the conventional side, while 82% had the excellent vegetation status on the right side. And this way we could monitor the effect of the practice that we decided to apply on our field, and not only use a visual aspect to confirm the effects. Additionally, as Luca mentioned, one of the most important things in agriculture is the end yield, aside from the end profitability. That's why we have decided to develop an analysis that can provide users with yield estimation, and this was our pilot estimation, where we took the previously ran analysis, overlapped them, and compared them in order to generate results. And in these tables, we can compare the most valuable data. On the conventional side, our estimation for the yield based on the previously generated data was 12.3 tons or 12.3 thousand kilograms, while the actual yield on that side of the field was 12.2 tons per hectare. On the precision agriculture side, our estimation was 13.5 tons per hectare, while actual yield was 13.4. With this data, we can conclude that the margin of error in both cases was approximately 1%, which, as somebody who worked in production, would be of great, in my opinion, is that it would be of great help in planning the overall production rates and logistics of the harvest. Finally, these are some of the major experiment results that we concluded during the past season on this field. First thing, as we mentioned, variable rate seeding had much better germination rate compared to the experimental parts. Managing fields with precision ag technologies has reduced the amount of plant stress as shown in the images of the field. And crops showed better health status after the application of variable rate fertilizer, and in the end showed increased productivity by 1.2 tons to be exact. Thank you everybody for your attention, and I would like to give word back to Luca.
Thank you, Nemanja, for sharing this insightful information about the project that you have. Now I would like to present our new product, our new package that we have, which is called the crop monitoring package. This new package is designed specially for the field crops such as corn, soybean, potato, sugar beet, tobacco, as you know, that we can analyze so many plants in our portfolio. And the difference with this package is that it is coming with a unlimited number of the analysis that you can request throughout the season. So this package is specially designed for growers, agronomists, or ag consultants who wants to receive the data that we were talking about today. So for those who don't have their own drones, please feel free to call us. We have partners all over the world, so we can provide you with the turnkey solution. So you just need to send us where are your fields, and you will start receiving data from us.
Thank you, Luca, and thank you, Nemanja, for this inspirative presentation of Agremo technology, and of course of new product crop monitoring. Just to remind our listeners to feel free and drop your questions on the right-hand side. And now it is time for our special guest, Pablo Navia, Product Development Manager from Adama. So, Pablo, please, the floor is yours.
Thank you very much. Well, thank you for the invitation. I've been working with Agremo since 2016. It's been more than 5 years in collaboration with Agremo, and I know you guys. I know your company since early in the game. Let's say we started exploring in Adama technologies for to assess our demo program with growers, and we were looking at several platforms, and some of them being drone deploy in Agremo. Since Agremo was specialized in agricultural algorithms, we decided that we would like to test it in more detail, and we did some trials in growers' fields with tools similar to what you are presenting now. Of course, Agremo has evolved over the time, but the same basics, I will say, same basics on working with aerial imaging to analyze fields, to check for crop stress, to check for stand count, to count the plants, and then there were more algorithms added to the system, like the new algorithms that we have now, including the variable rate technologies that allow us to do variable rate applications. So yeah, we did a lot of trials since 2016, and we started using Agremo more and more to evaluate our grower demos, and we use the online tool. So after a year of testing Agremo and getting to know the platform better, we got technical support from you guys, and we were assigned a person to work with. That's something very good about Agremo, is the technical support, and you have a person. You don't have a website, or you don't have a robot to work with. You have a real person. And back then, the real person that we had was Jovan Parusik. And I can tell you, we are still in collaboration with Jovan until now. So that's something very good about Agremo, the personalized support, and you get to know the other side, even though that we are so far away. We are in the US, you are in Europe, but we know each other, and we've been evolving in this collaboration. In 2017, we decided that we needed more customized a more customized tool to our needs in Adama, and we started working in a collaboration and more in deep with the Agremo team. In 2019, we launched our own Adama Eagle Eye powered by Agremo. So it's a version of Agremo, but it's customized to our needs in Adama. In this collaboration, we kind of developed new things, new uses to Agremo, and we can say that we, in this collaboration, we developed the micro plot tool that allow us to do small replicated research using aerial imaging to evaluate our trials. In this micro plot tool, we can actually do more in detail research on more detailed images. As you can tell, this tool allows us, and not only us but our collaborators, to collect data in a different way using remote sensing technology. So we are using this technology to validate the conventional data collection, which is is normally what we do in collaboration with researchers, with universities, with private researchers. We normally evaluate our trials with visual evaluations. Somebody in the field that is taking notes and walking in every plot, taking a lot of time, and on a summer day, it could be very demanding to a person. It's very hard to work in the field in a hot day, but we still do it. We are not replacing the normal and traditional data collection with drones. We are using drones to validate the field observations, and actually to have a better feel of the whole trial. We can look at every plot from the air without needing to walk every plot. So what we do now is less intensive in visual observations, but we still do it. but we don't kill ourselves in the fields in a hot day. We just go and take a look and validate what the drone is telling us. So it's kind of a combination, a hybrid system that we are using now. But thanks to the microplot tool that we developed with Agremo, that we can do those things. So it's very, I would say, very useful and very important to have this tool in our toolbox. Because it allows us to do more things in the COVID era, and we are still in the COVID era. But at the beginning of COVID, we were not allowed to travel. We were not allowed even to visit fields. So we used this collaboration with Agremo. We were able to send a pilot that lives nearby the region in our plots. We have plots all over the U.S., so we have a very nice pilot network. Agremo helped us to build that network, and they are in charge actually of sending the pilots to the fields. And we could send pilots to those fields where nobody could go, where nobody could even fly in an airplane or even go to that field driving, because those fields were locked. They were not able to get in. But we could send drones to actually map the fields, and we could do virtual field days, and that, I will say, saved the moment. And since then, our collaboration in our Adama Eagle Eye is being very useful for Adama. Now we are expanding to 7 countries in Europe, and we are offering the service to our countries. So with that being said, stay tuned. We are doing a seminar about this technology, about the microplot tool. Stay tuned. We will be doing that seminar with Agremo very soon. More details about this event will be announced by Nevena and the team. So thank you very much, and looking forward to the next webinar.
Thank you, Pablo, for your confirmation of Agremo's technology through your experience.
Thank you.
And of course, this is a great introduction for our new webinar R&D microplots monitoring. Just to remind once again our listeners to feel free and drop a questions, since now we are going to let's say Q&A session. Thank you for your questions already. There are a lot of them in our question box. I will start from the very first one. How can we get to know the stand counts using satellite imagery? Nemanja, could you please?
Yeah, I'll take that. So essentially, satellite imagery is good in stand count only in forestry. Unfortunately, even the best satellites don't have the high enough resolution to do stand counts in regular field crops. That is why we are mostly focused on drone recordings for this analysis, even though in general, Agremo can do analysis on satellite imagery. I hope that answers your question.
There is a question. Do you recommend using your software for Wineyards? Do you see any software involvement to better serve Wineyards? Luca, what's your answer?
Well, yeah, we throughout the time that we are working with multiple type of the growers, we we received many analysis requests, and we did certain R&D to try to apply our analysis on Wineyards, but our biggest challenge was there to provide the data about the Wineyards health in the right moment. So the bettings or the diseases or the pests starts first to shown up under the leaves, and in the time when they spread on above, it's already too late to react. So since we are analyzing drone data, which gives us a 2D perspective of the bird's eye view, it's very hard to detect in Wineyards those kind of stresses which are important. So yeah, there are some analyses that we can apply, for example, the plant counting or to detect stresses or canopy coverage, but those very, very important and specific stress, we are unfortunately unable to detect due to the point of the view that we are having.
Okay, thank you. William Smart asked, can I generate VRT maps based on Agremo analysis? And can they be used with any onboard navigation? Nemanja, I think you are the right person for this.
Yes, I will take this one. Yes, so Agremo does support generation of VRT analysis for both VRA fertilization and VRA spraying. At this moment, we don't support variable rate seeding, so that may come in the future. Currently, it is unknown. And yes, you can use them in any onboard CPU that you have. Essentially, you will get a basic shapefile structure that can be imported in any navigation. The only thing that you have to respect is the structure of folders required for input into the navigation. For example, if you're using John Deere, you'll only need to create a folder RX and put the shapefiles inside it. If you're maybe using Trimble, you will need AGGPS, and inside you will have the folder prescription, and in it you will put shapefile or RX file to be more precise, and then you can put it in your onboard computer and everything will work just like with any regular variable rate application.
I think that Pablo will be the right person for this one, since he has a great experience. Daniel Correa asks, some farmers are still hesitant to use drones in their fields. Do you have insights on how to better approach and sell more?
Yes, I agree. There are some situations where farmers don't have the technology yet, or think the technology is not very accessible to them. I think a good solution, and that's something that we are doing also, is just relying on third-party providers, which are every time as the time is passing, this service is more accessible to everybody. So I will say, based on my experience, the use of third-party providers is the best solution.
Thank you, Pablo. Mr. or Mrs. Morata asked, you mentioned you use soil samples for variable rate fertilizer. How many soil samples have you collected in 10 acres? Nemanja, could you please be so kind to answer on this? What was the additional cost of sampling plus analyzing the soil?
Yes, of course. Mm-hmm. So our estimate, so when we were taking soil samples, we were taking one sample at 0.5 hectares. I believe that's somewhere around 1 acre, I believe. So essentially, we were taking 10 samples, then create a representative sample and analyze it for NP and K. The cost of that soil sample was around $20 per soil sample. So essentially, we had a very low amount. So it was maybe $80 for the entire field in the experiment that I was talking about in the presentation.
Thank you. I think, Luca, this is for you. How can we buy all this?
Yeah, feel free to contact us on sales at Agremo, and we will send you everything that is necessary.
Perfect. Brent asked, can you analyze these reports, weed control, plant stress, water lodging count, be generated using standard drone RGB? So, Nemanja, I think you can answer on this.
Of course. So yes, the entire point of Agremo is to analyze RGB images without needing any expensive sensors. And I've seen a lot of people ask this exact question. So you can use essentially any RGB equipped drone, as long as it has a resolution of, let's say, 20 megapixels and higher, and you respect some basic ground sampling distance rules, such as be in the GSD of 2.5 centimeters pixel and fly at around 70 meters, and you should have a good enough map that Agremo can analyze. And as I said, just a basic RGB map. But also I want to mention that if you have a multispectral drone already, don't worry, we can also analyze multispectral images, so you are on the safe side, even or in both kinds of sensor that you may be using.
I have one question for Pablo. What was the planting method used in each of the plots, conventional versus precision ag plots?
Our plots are still planted conventionally, not yet on precision ag, since these are small replicated plots. So yeah, the answer is conventional.
Okay. Let's say one more for yield prediction. What ground truth data do you use, Luca? Do you mix in NDVI in order to produce more accurate yield predictions, or Nemanja?
I think Nemanja would be more.
Okay.
I can take this. First, as I said in the presentation, this was a pilot development process of the yield prediction, and we're still improving it. It will be much better in the future. At the moment, so first I would like to say you will need a recording in early reproductive phases of vegetation. And it currently only works on selected field crops such as corn, wheat, barley, and sunflower. And we do not at the moment use NDVI. We use a mix of historical season data. So you start monitoring your crops with Agremo from start to finish, and we take all the analysis, all the data that was gathered throughout the season, and then overlap them, and we generate a map that is creating predictions of yield potential and essentially the yield data with it.
Okay. I think we covered all. Since we didn't, we will answer later. Thank you, Nemanja. Thank you, Luca. Thank you, Pavlo, as our special guest. We have come to the end, and I would like to sum up. The current value of the global precision agriculture market is $7.4 billion. And the estimation is that it will jump to $23 billion in next 8 years. So, globally speaking, we strongly believe that precision ag technologies will find its place in all agricultural production systems in the near future. And that is not a dream, that's our reality. As you already heard from Pablo, we will definitely see you soon, very soon, in April, on our next webinar dedicated to our new product, R&D microplots monitoring. Just to remind you that you will receive immediately an email containing a link to this broadcast, so that you can watch it later or share it with someone who might be interested too. In a case you need some clarification regarding our new products or new sales possibilities, please write an email on sales@agremo.com. What else? Thank you for attending. Thank you for your time, and see you soon. Bye.